Hey everybody, Chris McClure here. We're going to do a quick review on how to factor polynomials. Alright, so here's the thing. When we talk about factoring a polynomial, we're talking about trying to write it as a product of two or more factors. Alright, and so we'll start off with some fairly small polynomials that we can factor. In fact, we have on this slide some binomials that have a common multiple for both terms, like the 2x plus 4. Notice that there's a common multiple of 2, so you can factor out that 2 to make a 2 times x plus 2. That's kind of doing the opposite of the distribution of the 2 using the distributive property. We're factoring out the 2 from both terms. The 3x minus 6, factor out a common multiple of 3 to make 3 times x minus 2. Now the 2x squared minus 4x plus 8 is not a binomial, it's a trinomial. But we can at least factor out a common multiple of 2 to make 2 times x squared minus 2x plus 4, and so forth. Hey, x squared plus x, notice there's a common multiple of x, so you could write x squared plus x as x times x plus 1. X cubed minus 3x squared has a common multiple of x squared that you can factor out to make x squared times x minus 3, and so forth. So we're going to use that as our guide as we move forward in factoring more and more complicated polynomials. Now, here we have just a quick crib sheet to allow us to factor some of the more common forms of polynomials, including difference of squares, which we could write as the x minus a times x plus a form. Or if you have a perfect square of a binomial, either with the plus version or the minus version, sum of 2 cubes, sum of the difference of, or the difference of 2 cubes. All right, so whenever we see a polynomial with one of these special forms, then we can quickly factor it using the right-hand side of the formulas there. So, for example, we have x squared minus 4. Recognize the 4 as 2 squared, and then you can use this difference of 2 squares sort of factorization to write this as x minus 2 times x plus 2. Okay? For example, or if you have x cubed minus 1, well, recognize the 1 as 1 cubed. And then you could use this form right here, where you'll have the x minus 1 times the x squared plus x plus 1 as the factorization, like you see there. Okay. How about the x cubed plus 8? Think about the 8 as 2 cubed. So then we have the sum of 2 cubes, which will give us this factorization, where we'll have the x plus 2 times x squared minus 2x plus 4. Okay, like you see here. Now here we have x to the 4th minus 16. Well, the 16 is 2 to the 4th, but we don't see a little formula for how to factor the difference of 4th powers. So, but what we can do is recognize this as a difference of squares, the squares being x squared squared minus 2 squared squared. Like that. Aha. And then we can use this form right up there. Okay, so then we'll have the factorization of the x squared minus 4 times x squared plus 4. Well, then the x squared plus, or the x squared minus 4 could be written as x squared minus 2 times x squared plus 2, then, which is another difference of 2 squares. So we'll have this complete factorization. Okay, complete factorization. Now, the x squared plus 4, there's really not much that we could do with it and still remain within the realm of real numbers. X squared plus 4 is what we call prime. It cannot be broken down anymore. Okay. All right, let's take a look at factoring perfect squares. And this is mostly a matter of just recognizing patterns. Now you have x squared plus 6x plus 9. Notice the 9 as 3 squared. And notice the 6 as 2 times 3. So we have it in the form of x squared plus 2ax plus a squared, where a is 3. Well, then that factors as the x plus a squared. So in this case, we'll have your x plus 3 squared. Okay? Let me clear off the ink here. So we have this factorization of x plus 3 squared. So if you recognize that pattern, then the rest of these will follow suit. The 3x squared, recognize as that as the 3x quantity squared, minus 6x, which is 2 times 3x, plus 1, which you could write as 1 squared. The 2, 3x right here, you can also think about as 2 times 1 times 3x. All right, so this will factorize as 3x minus 1 squared. All right, let's look at this last one, 25x squared plus 9 on the back end plus a 30x in the middle. Now the 5x squared, 5x quantity squared, and then you have a 3 squared on the back end. And then in the middle, that 30 is the 2 times 5 times the 3. So you could see the factorization for this one is going to be the 5x plus 3. The 5 coming from this guy and the 3 coming from this guy. Okay. All right, let's factor other trinomials that are not perfect squares. Now, here we'll focus on trinomials where the leading coefficient is just 1. And then here in a couple minutes we'll move on to trinomials where the leading coefficient is not necessarily 1. Now, I'll show you the method that they teach in the book, but I'll show you my method, which is called the AC method, which I think is a little bit easier to remember. Now, let's go ahead and dive right into this. We have x squared plus 7x plus 10. Now, you look at this 10 and think about the different ways that you could write 10 factorized as a product of two numbers. You could write 10 as 1 times 10, and you could also write 10 as 2 times 5. But which two factors will add together to make 7? And the answer is the 2 and the 5. So that tells you that you could write this as x plus 2 times x plus 5. Because when you FOIL this out, you'll have what? X times x is x squared plus x times 5 is 5x plus 2x plus 2 times 5 is 10. Now, my AC method basically asks the question. You have 10 at the end, right? That 10 is the result of multiplying the last parts of each binomial, the last terms of the binomials that you're multiplying together. But they add together to give you that middle coefficient. So we ask the question, what two numbers can you think of whose product is 10, but whose sum is 7? And the answer is 2 and 5. So we could write the x squared plus 7x as x squared plus maybe 2x or 5x. But let's just write 2x first. And then we have 5x plus 10. So all we did was just that we rewrote the 7x middle term as 2x plus 5x. And then you can factor by grouping, by looking at these two first terms now, and factor out the common x, and then you have x plus 2 plus, and then for the last two terms you can factor out a 5 times x plus 2, and then you can then factor out the common x plus 2 to give you 5 plus x, which I'll write as x plus 5 times x plus 2. Folks, either method works for me. I prefer the AC method in teaching my students because they're able to always have a way of getting the factorization right each and every time. Okay, so moving along here without having to do all this guesswork that they show you in the textbook. X squared minus 6x plus 8. Look at the 8 there at the end. And then look at the negative 6 in the middle. Now what we want to do is think of two numbers whose product is 8, but whose sum is negative 6. And the answer is going to be negative 2 and negative 4. So we can rewrite this trinomial as now a quadrinomial, and it doesn't matter what you put down, minus 2x first or minus 4x first. I'm going to write minus 2x and then minus 4x and then plus 8. So look, the only thing that I changed from this step up here down to here is just that I rewrote negative 6x or minus 6x as minus 2x minus 4x. That's all I changed. But now we can go ahead and factor out an x from these first two terms and factor out a minus 4x, or sorry, a minus 4 I should say, from these last two terms. Leaving this with a common factor of x minus 2, which you can factor out, leaving you with an x minus 4. So we have x minus 4 times the x minus 2. And boom, we're done. So x minus 4 times x minus 2 is the factorization. All right? Moving along here. Here we have x squared minus x minus 12. Think about two numbers whose product is negative 12, but whose sum is negative 1. And the answer is negative 4 and positive 3. So you can rewrite the polynomial as x squared minus 4x plus 3x minus 12. Factor out the x from the first two terms. Factor out the 3 from the last two terms. And notice that you have an x minus 4. You're always going to have a common binomial factor at this step when you do this factorization method. And boom, you're done. You are done. Moving along here. Here we have x squared plus 4x minus 12. Think of two numbers whose product is negative 12, but whose sum is positive 4? And the answer is 6 and negative 2. Because 6 times negative 2 is negative 12. 6 plus negative 2 is 4. So let's go ahead and rewrite the polynomial x squared plus 6x minus 2x minus 12. So again, I just rewrote the 4x here as 6x minus 2x. Now, factor out an x from this x squared plus 6x, because, hey, x is what's common between those two terms. And then you notice the minus 2x minus 12, factor out a minus 2. And that gives us x plus 6 as well. So factor out that common x plus 6, leaving you with x and minus 2. And boom, there's the factorization. Now, notice that for these trinomials where the leading coefficient is 1, then when you do the factorization, that these two numbers here will multiply to give you the negative 12 in the polynomial, and they'll add together to give you the coefficient for the middle linear term. Okay? So that should help you with your factorization. Now, here we have x squared plus 9. Is that a prime polynomial? Meaning, can you factor it? Yes or no? And the answer is no. And my simple question is this: if it wasn't prime, then we would need to find two numbers whose product was 9, but whose sum was 0. And the answer is there aren't any such numbers. That's why x squared plus 9 is a prime number. Okay? So you can go through all the different ways that you can factor 9 as the product of two numbers, but when you add them up, add up those numbers, those factors for 9, you don't ever get 0. So that's why x squared plus 9 is prime. So whenever you have a polynomial of the form x squared plus some positive number, then that polynomial is a prime polynomial. Let's review how to factor by grouping for a polynomial. Say, look, you see something that's in common to all of the terms, then factor it out. You see x squared plus 2 is common for both of these terms, factor out the x squared plus 2, leaving you with an x and a 3. Alright, so that would give you the x squared plus 2, which is this guy right here. There's your x squared plus 2. And then leaving you with the x plus 3, which is that one right there. Now let's look at this guy right here. What do you notice as factors that are common to both terms? Well, you have x minus 1. Not only x minus 1, you got two factors of x minus 1 here and also within there. I know there are three factors there, but what factors are common to both terms? And the answer is two factors of x minus 1 and three factors of x plus 2 there and there. So factor out two factors of x minus 1, meaning x minus 1 squared, and also an x plus 2 cubed. Factor out both of those. That's what we factored out right there. And when you do that, what you have left over is an x plus 2 factor from right here, and you're left with an x minus 1 factor right there. All right, I'm going to erase all the ink on the slide here. And then once you get to this stage, just multiply and combine like terms, okay? And when you multiply it out, 3 times x plus 2, that's 3x plus 6, times the 4x minus 4. Add the 3x plus 4x, add the 6 plus negative 4, and you get the 7x plus 2. Okay? And boom, we're done factorization by grouping. All right? Here we've got this actually this quadrinomial, 4-term polynomial. We can factor by grouping. Now, we're not able to do this with every third degree polynomial, but for this one we can. Just look at the first two terms, look at the last two terms, and see if there are any common factors that you can pull out. Like for the first two terms, there's two factors of x, so factor out the x squared. And also for the last two terms, factor out a 2. And notice now that you have a common factor of x minus 4. So when you factor out the x minus 4, you're left with the x squared plus 2. Okay? Moving on here. Just repeating what I did there. Now, let's talk about factoring a trinomial where the leading coefficient is not 1. And we'll use the so-called AC method. The AC method. Basically what we'll do is we'll multiply the leading coefficient times the constant term. And then we'll ask ourselves the question, what two numbers have a product of whatever A times C is, but whose sum is B? That's what we're saying here. That's what step 2 is. And then when you find those two numbers, call them little a and little b, then you could just break up the middle linear term as the sum of those two numbers that we're trying to think of, and then you can factor it by grouping. So let's try our hand at this. Now you have 2x squared plus 5x plus 3. Now let's take 2 times 3. That's the A times C, right? 2 times 3 is 6. Now think of two numbers whose product is 6, but whose sum is 5, which is the linear coefficient. And the answer is 2 and 3. So you could write that 5x as 2x plus 3x or 3x plus 2x. Either way is still going to eventually end up the same way. So I'm just going to write this as 2x squared plus 2x plus 3x plus 3. But like I said, this term could have just as well been 3x, and this could have been 2x. Doesn't matter. All right. Now from these first two terms, factor out a common factor of 2, x, leaving you with x plus 1, right? From the last two terms, factor out a common factor of 3, and then factor out a common x plus 1 from both of those terms, leaving you with a 2x plus 3. Okay? And folks, that's all there is in factoring that polynomial using the AC method. If you understand that, then you can do any polynomial. Okay? Just some polynomials are easier to do with others. Believe me, when we get to using the quadratic formula, that will definitely solve any trinomial over the real numbers. All right, so this kind of shows what it is that we just did here. Let's try another one. We have 2x squared minus x minus 6. So let's use the AC method. 2 times negative 6 is negative 12. Think about two numbers whose product is negative 12, but whose sum is negative 1. And the answer is negative 4 and 3. So you could write the polynomial as 2x squared minus 4x plus 3x minus 6. Like I said, all we're doing is we're rewriting the negative x as negative 4x plus 3x. And now we can factor by grouping. from the first two terms, factor out the common factor of 2x, and then we have x minus 2. And then from the last two terms, factor out a common 3, and then factor out a common x minus 2. And we're done. You can always check your work, folks. That's one of the great things about most math problems is that it's fairly easy to go back and check your work. Now, how do you check your work? Well, you could FOIL this out. 2x times x is 2x squared. 2x times negative 2 is negative 4x. You can take 3 times x is 3x. And 3 times negative 2 is minus 6x. And yes, indeed, that gives us our original polynomial when you take the negative 4x plus 3x, which gives you minus x. Okay, moving along here. So I'm just kind of skip over this stuff. Uh-oh, we need to restart PowerPoint. I'm going to pause this real quick and I'll resume here in a minute. Okay, folks, I'm back with you here. Had to restart PowerPoint. So we just finished factoring this guy. Sorry, I lost all of my ink annotations. I usually like to maintain my ink annotations. Sorry, it looks like PowerPoint's having a problem here. And it looks to be at the same point as last time. I don't know what's going on with it. I'm using a tablet PC. And once in a while I've had troubles with this. Let me just go ahead and skip to this next slide right here. Okay. Okay, so let's continue here. The previous slide was this guy right here. So we were looking at factoring this guy using the AC method. Hopefully everyone understands. Let me know if you still need some help. Practice it though. Okay, so you see the summary here. This gives you some hints on how to factor some polynomials by looking for any common factors throughout all the terms that you can factor out. Look at for any special forms, difference of squares, difference of cubes, and so forth. Look for any perfect squares. Use the so-called AC method together or maybe separately with grouping. All right, now let's talk about another way that we can factor, and that's completing the square. Now, what we mean by completing the square is that we might see an x squared plus bx form in our polynomial, where b, of course, is just a number, x is a variable. Now, in order to convert this into a perfect square of a binomial, is we will add a number, a constant term, to the end, and that number that we add will be half of b squared. Okay? And the reason for that, let's just go ahead and write x squared plus bx here. Now when we write where we are adding 1/2 b squared and then subtracting it, to keep it balanced. Then this right here will be the perfect square of x plus 1/2 b. Okay? That's why. So what would we add to y squared plus 8y in order to complete the square? Well, you take half of this 8, which is 4, and square it. So you would add 16. And that would give you y squared plus 8y plus 16, which you can then factor as y plus 4 squared. Okay, you get it? Let's go through these other ones fairly quickly. X squared plus 12x. Take half of the 12, which is 6, and square it, so you get 36. 36 is what you would add to complete the square. So now you would have the polynomial x squared plus 12x plus 36, which you can then factor as x plus 6 squared. Next one, a squared minus 20a. Look at the linear coefficient, the minus 20. Take half of negative 20, which is negative 10. Squared is 100. So you'll add 100. The number that you add to complete the square is always going to be positive, by the way. So add 100. And then factor as a minus 10 squared. Last one, folks, p squared minus 5p. Take half of negative 5, which is negative 5 halves. Squared, you get 25 fourths. So add 25 fourths to get this polynomial here. Factor it as what? What squared, right? It's going to be p minus 5 halves squared. The 5 halves coming from the square root of the 25 fourths. And the minus part being from this polynomial being a minus there and a plus there. All right. Here's a different way that you can think about completing the square. So as you look at this big square, you know, what is the length of each side of the big square? Well, it's going to be y plus 4. And y plus 4 times y plus 4 will give you y squared plus 8y plus 16. Well, here we have the y squared. We've got 4y and the 4y, so that must mean that this is 16 in order to complete the square. Okay, so that's it for us today. And I'll just not bother keeping the ink annotation, seeing how the PowerPoint decided to have problems with us earlier. But in the future, I'll try to keep whatever ink annotations we make here. All right, so hey folks, I know that this is section R5, and we still have 3 more sections to finish chapter R, but I see that several of you are chomping at the bit to get through this chapter, because there's about 3 or 4 of you who have done all of the chapter R homework out through section R6 with 100%. So that tells me that you're raring to go. So what I've done is, just this afternoon, I've created a quiz, fairly lengthy. It's 36 questions. A lot of the problems are fairly easy, but some of them will take some time. But I've posted it on Blackboard. It's multiple choice. It'll be a 90-minute quiz. Open book, open notes, but it'll be solo work. You need to work alone. You can't get any help from anyone. It's a web-based quiz that you could do right there on Blackboard. So just navigate to the course content and then the quizzes folder. So, and also on my math lab, I've posted the homework from section R7 and also R8. So now all of the homework from Chapter R is posted. So after you have worked, for those of you who are really anxious to work ahead, after you've worked all the homework from Chapter R, then feel free to go ahead and take the quiz. The due date for that quiz is, I think I made it June 14th, okay, June 14th. But let me just warn you, though, that you'll only have one try for each attempt at a question, okay? Or, I'm sorry, each time that you come to a question, you have just one chance to click your question and move on to the next. You cannot go back to change your answer. So make sure that you've got an empty bladder. So sorry to be so blunt, but this is not going to be 90 minutes in one continuous setting. So empty bladder, you're comfortable, you're prepared, you got lots of scratch paper, open book, open notes, and your calculator. So work out your problem and then answer your question and then move on to the next question. You have 36 questions from all of Chapter R. And then you'd submit, and your score will automatically populate in the gradebook of Blackboard. Okay? So let me know if you have any questions on this. You don't, have to do the quiz right away, of course. Whenever you are finished with all of the Chapter R material in my math lab, though, then feel free. Now, right now, today is Thursday, May 30th. I made it to where the quiz will be available for you to play with starting midnight tomorrow night, meaning midnight as Friday transitions to Saturday. Okay, so that's it for now, and I will record a lecture on R6 tomorrow. Okay, take care, and goodbye for now.